So in this video, we're going to do one of the sums based on the Macaulay duration and modified duration related questions. Okay, so these are one of the most important topics when it comes to fixed income part of CFA program. And basically, you should know that in like when the market price increases, when the interest rate increases, the price of a bond decreases. Right? This is a basic of a bond pricing in the fixed income part. And Macaulay duration bond helps us to understand by how much does a bond price change with respect to the interest rates. So uh, I saw a couple of methods that were shown in the curriculum, which how we calculate is by taking the weights and cash flows of each of the coupon payments and then multiplying and adding. Like it takes a lot of time. This is what I found one of the easiest approaches to calculating Macaulay duration. Now, there are two formulas that we will discuss about these. It's that first of all you need to know modified duration. So the modified duration is equal to PV minus PV this. Okay, wait a second. Right. So the modified duration is equal to PV minus uh, minus PV plus whole upon 2 into PV0 into change in the yield. Now, what are this? This is the price when the interest rates are falling. This is the price when interest rates have risen, and this is the price at which we are currently at. Now, what we can do is, so to find out the modified duration, also the other formula we're going to use is that Macaulay duration bond is equal to modified duration into 1 plus R. These two formulas will be used in this. Now, first we'll find this. Now, what we want to do? We have the universal bind a 6% annual payment bond, 3 years bond has. So if we put in our calculator, coupon rate as 6, N as 3, and your YTM as 8%, you will get PV as this. Also, the notional or face value or future value is 100. So you will get your PV as 94.8. Right? This is what you're going to get. Now what we have to do is we have to estimate a change in the yield to maturity. Right? So PV less PV0 and PV plus. We are going to make the slightest change in the yields. Okay, slightest change of 1 basis point is nothing but 0.01% change, right? So here what I'm going to do is I'm going to decrease the interest rates by 1 basis point. So this is going to be my YTM here, which is going to be 7.99%. Here my YTM is as per the question, it is 8%. Here my YTM is 8.01%. Right. Again, we're going to, in our financial calculator, we're going to put N as 3, and we're going to put coupon rate as what it was above 6, or else see coupon rate 6, FV is 100. We just want to discount back the PV when the interest rate has fallen. Now, I have calculated the present values when the interest rates had fallen, and the present value which we had already, and the present value when the interest rates had risen. Now, you can easily understand when the prices had fallen, the price of the bond, interest rates had fallen, the price of the bond had increased, right? And when the interest rate rose, we can see that the price of the bond fell. This is what you basically interpret from this. Now, what we're going to do is going to put these values into this formula, PV minus this, PV minus PV plus, that is on interest rate horizon, into 2 into this, into change. So the change should be in decimals. So 0.01% in decimals, it would be 0.0001. You should be using this number, right? Now, the value which you are going to get after calculating the modified duration, to in order to calculate what is asked, Macaulay duration, MCD, we just need to put this value MD into 1 plus 0.08 in decimals of percent, that is 1.08 into modified duration is equal to MCD, and then you will find MCD as 2.83, which is the required answer. This shows that when the market interest rates have a change by 1%, the price of the bond increase or decrease by this duration, by this price. So this is basically more or less the interpretation of this. And yeah, like this is by far the most easiest method. You can also go for the like really tough formulas for hard to remember formulas for MCD and the table method, but I think this is, in order to squeeze in time, this is easiest. Thank you.